So now we are going to start our unit 2. So we are going to see the concept of numerical solution of an ordinary differential equation, and in that we will find approximate solution of ordinary differentiable method, and to find this we will use Milne's predictor corrector method. Now what Milne's predictor corrector method is, it is nothing but basically two formulas. First one is predictor formula and the other one is corrector formula. So we have to find an approximate value of y. For example, if you are given values x0, x1 up to so on, xn, and value of y at x0 is given, value of y at x1 is given, then you are asked to find value of y at xn. Another notation for y of x0, y of x1 and y of xn is nothing but y0, y1 up to so on, yn. Okay, so now you'll be given certain ODE in the form of dy by dx equals to this. Another notation for this is y dash, and it will be some function in x and y, and some initial conditions will be given. For example, x0 equals to this and y0 equals to this, x1 equals to some another number and y1 equals to another. And with the help of initial conditions, you have to find, or you have to determine the value of yn. So it is nothing but a multi-step method, and to find the value of y at xn or xn plus 1, we have to use values, previous values, yn minus 1 up to so on, initial conditions y1 y, and y0. So now if you have a dE in the form of this dy by dx equals to y dash, and this y dash is in the form of a function in terms of x and y, and you are given x0, x1, x2 up to so on. So these are the initial conditions where there is a common difference between the two consecutive numbers. So suppose that difference is h, and the corresponding value of y at the certain point, so y of x0, that is y0, is given, then y1 is given, y2 is given, and y3 is given. You have to make use of this initial conditions, and you have to use predictor and corrector formula. So first, predictor formula is used to find the value, and then to make it more accurate, to make the value more accurate, we use the corrector formula. So what is the predictor formula? So it is denoted by P, and it is yn plus 1 equals to yn minus 3 plus 4 upon 3 h 2 into y dash n minus 2 minus yn minus 1 dash plus 2 yn dash. So this is the predictor formula. We have to use initial conditions to get yn plus 1 value, and then we have to use corrector formula, which is yn plus 1 equals to yn minus 1 plus h upon 3 yn minus 1 dash plus 4 yn dash plus y dash n plus 1. So yn plus 1 dash. So this is the corrector formula. With the help of this, we can correct the given approximated value which we have found from the predictor's formula. So now let's see an example. So suppose we have given dy upon dx, which is equal to 1 upon 2 x plus y, and we are given the initial condition y0 equals to 2, y of 0.5 equals to 2.636, y1 is 3.595 and y of 1.5 is 4.968. You have to find the value of y of 2. Okay, so now as we are given initial conditions and one function is there which is y dash, so y dash is 1 upon 2 x plus y. We have to use Milner's predictor corrector method. So basically we have values for x as 0, then we have 0 0.5, 1 and then 1.5. So these are the values for x. So you can denote it as x0, x1, x2, x3, and you have to find value of 2, so let it be x4. Now corresponding value for y will be, so y0 is 2, then we have 2.636, then we have 3.595 and then 4.968, and we have to find the last one. So this let it be y0, then y1, then we'll have y2, y3, and we have to find value of y4. Now here if you see, then the consecutive difference between the difference between consecutive terms of x, it is 0.5. So here we have h equals to 0.5. We have to find y4. So now we will use the predictor formula. So using predictor formula, what we have is yn plus 1 equals to yn minus 3 plus 4 upon 3 h into 2 yn minus 2 dash minus yn minus 1 dash plus 2 yn dash. Okay, so now here we have to find y4. So here n equals to 3, so y4 will be equal to, so now 3 minus 3, so here it will be y0 plus 4 upon 3, value of h is 0.5 into 2 into y dash of 1 minus y2 dash plus 2 into y3 dash. So now we have to find values of y1 dash, y2 dash and y3 dash. For this we need to use this given formula, that is y dash equals to 1 by 2 x plus y. So to calculate y1 dash, what we have is y1 is given as 2.636 and respective x1 is 0.5. So with the help of this you can find y1 dash equals to 1 upon 2 x plus y, so 0.5 plus 2.636, which is equal to, so after calculation you will get it as 1.568. So this is the value of y1 dash. Similarly, to calculate y2 dash, you have to do x2 plus y2 upon 2. You know value of x2 and y2. So substituting its value, you will get the answer as 2.2975. Okay. Similarly, we can find y3 dash. So it is x3 plus y3 upon 2. So this will give you 3.234. Now substituting values of y1 dash, y2 dash and y3 dash in the equation, will get y4, which is equal to y0 is given as 2 plus 2 upon 3 into 2 into 1.568 minus 2.2975 plus 2 into 3.234, and this value is 6.871. So this is the predicted value of y4, and now we need to correct this value. For this correction we have to use the corrector formula. So now the corrector formula is yn plus 1 equals to yn minus 1 plus h upon 3 yn minus 1 dash plus 4 yn dash plus yn plus 1 dash. Now if you observe, then we have to find yn plus 1 dash first. So for this we have to use yn plus 1 value as 6.871, which we have find it in with the help of predictors formula. So now here also n equals to 3, so y4 will be equal to, now n minus 1, so y2 plus h upon 3 into y2 dash plus 4 y3 dash plus y4 dash. Okay, so now first we need to calculate y4 dash, because we don't have that value. We have value for y2 dash and y3 dash. So for y4 dash we have to use x4 plus y4 upon 2. Now x4 is 2, so 2 plus y4, we have to make use of this y4 which we have calculated from predictors formula. So it is 6.871 upon 2, which will give you 4.4355. So now after substituting this value y4 dash in this correctors formula, we will get y4 equals to y2, which is 3.595 plus h is 0.5 upon 3 into 2.2975 plus 4 into 3.234 plus 4.4355. So this is y4 will be 6.8731. So this is the corrected value of y4. So this is how you have to solve any given equation or given for sum by using Milner's predictor corrector method. Now let's see a second example. So we have to find the solution of dy by dx equals to x plus y square, and the conditions for this is y of 0 equals to 0, y of 0.2 equals to 0.020016, y of 0.4 is given as 0.080512, and y of 0.6 is given as 0.183888. Now we have to find the value of y of 0.8. So these are the initial conditions. We have to find y of 0.8. So let's see how it is. So if this is x0, which is 0, this is x1, which is 0.2, then we have x2, which is 0.4, then x3, which is 0.6, and x4, which is 0.8. Now the value of y at x0, that is y0, is given as 0, then y1 is given as 0.020016, then y2 is given as, that is value of y at 0.4 is 0.080512. Similarly, y3 is given as 0.183888, and what we have to find is y4. So to find y4, now as we know that the difference between consecutive values of x is h, which is equal to 0.2. Now we have to use the first predictor formula. So predictor formula is given as yn plus 1, which is equal to yn minus 3 plus 4h upon 3 2y dash n minus 2y dash minus n minus 1 dash plus 2yn dash. So now we have to find y4. So we have here we have n equals to 3, so y4 equals to y0 plus 4h upon 3 2y1 dash minus y2 dash plus 2y3 dash. So this is a first equation. Now what is given is y dash, that is dy by dx, equals to x plus y square. And now to use the predictors formula, we need the values of y1 dash, y2 dash and y3 dash. So now y1 dash can be calculated as x plus y square, so x1 plus y1 square, which is equal to 0.200400064. Similarly, y2 dash can be calculated as x2 plus y2 dash, which is equal to 0.40648282. Now last one is y3 dash. Again it can be calculated as x3 plus y3, sorry, it's not y3 dash, it's y2 square. So x3 square, which is equal to 0.633814796. Now after calculating the values of y1 dash, y2 dash, y3 dash, you can substitute these values in this equation 1. So this equation becomes y4 equals to y0 is given as 0, so 0 plus 4 upon 3, h is 0.2 into 0.400800128, that is 2 into y1 dash, because y1 dash is this, so multiplying it with 2 you get this. So minus y2 dash, so y2 dash is 0.406482182 plus 2 into y3 dash, so y3 dash is this, so 2 into this will give you 1.2676259. So solving this, you will get y4 will be approximately equal to 0.3365. Now this is the approximate value and we have predicted this value by predictor formula. Now we have to correct this. So using corrector formula is C yn plus 1 equals to yn minus 1 plus h upon 3 yn minus 1 dash plus 4 yn dash plus yn plus 1 dash. Okay. So now n equals to 3 will give you y4 equals to y2 plus h upon 3 y2 dash plus 4 y3 dash plus y4 dash. Now we have already found out y2 dash and y3 dash. We need to calculate y4 dash, and to calculate this y4 dash we will make use of this y4 which we have calculated using predictors formula. So now to calculate y4 dash, we can write here x4 plus y4 square, which will give you 0.913233225. So substituting this value in the correctors formula, you will get y4 equals to y2. So y2 is nothing but this. So 0.080512 plus h upon 3, so this will give you 1 upon 15 into y2 dash. We have calculated 0.4064828182 plus 4 into y3 dash, so multiplying 4 with this you will get 2.535259184 plus, now what is this y4 dash? So y4 dash is nothing but 0.9132325. So after calculating this, you will get y4 as y4 will be equal to 0.3375. This is the required value, and that's the value of y at x4, that is 0.8. So this is the required answer. See one more example. Now in this case, it is given in the tabular form, that is x, y, and x values are minus 0.1, 0, 0.1, 0.2, and y values are 1.0900, 1.0000, 0.8900, and 0.7605. So now you have to use Minay's method to find the value of y of 0.3. So now we are given x0, which is nothing but, if this is x0 is considered as 0, then x minus 1 will be given as minus 0.1. Then next one is x1, which is 0.1, x2, which is 0.2, and the last one x3, which we have to find its value, that is 0.3. Similarly, y values are yn minus 1 is given as 1.0900. Second one is y0, which is 1. Then y1 is given as 0.8900. y2 is given as 0.7605, and y3 is given, we have to find y3. Okay, so now to find y3, we know that h equals to the difference between two consecutive values of x is 0.1. So now first we will use predictor's formula. To use predictor's formula, yn plus 1 equals to yn minus 3 plus 4h upon 3 to yn minus 2 dash minus yn minus 1 dash plus 2yn dash. Here n equals to 2 because we have to find y3. Therefore, y3 will be equal to y1, that is y minus 1 plus 4h upon 3 to y0 dash minus y1 dash plus 2y2 dash. And this is the first equation. We have to calculate y1 dash, y2 dash, and y0 dash. So to calculate this, okay, so the equation given was x square plus y square minus 2. So this y dash was given as this x square plus y square minus 2. So now first we need to calculate y0 dash. To calculate this, we have x0 square plus y0 square minus 2, which is equal to x0 is 0, y0 is 1. So after calculating this, you will get minus 1. Similarly, y1 dash will be equal to x1 square plus y1 square minus 2. After substituting the values, we will get minus 1.1979. Similarly, y2 dash will be equal to x2 square plus y2 square minus 2, which will be equal to minus 1.3816. So we have calculated all these three values. We need to substitute it in the predictor's formula. So we'll get y3 will be equal to y0 y minus 1. So y minus 1 is nothing but 1.0900 plus 4 upon 3, h is 0.1, and then 2 into minus 1 plus 1.1979 plus 2 into minus 1.3816, which is our y2 dash. Now this will give you 0.6146. So this is y3. Now we have to use corrector's method. Corrector's method is given as c equals to, c is the notation, so yn plus 1 equals to yn minus 1 plus h upon 3 yn minus 1 dash plus 4 yn dash plus yn plus 1 dash. Now y3 equals to y1 plus h upon 3 y1 dash plus 4y2 dash plus y3 dash. So now we need to calculate y3 dash using this y3. So y3 dash will be equal to x3 square plus y3 square minus 2. This is equal to minus 1.5323. So now substituting this y3 dash in this characters formula, we will get y3 equals to 0.89 plus 0.1 upon 3 into y1 dash. Y1 dash is nothing but minus 1.1979 minus 4 into y2 dash. So 4 into y2 dash is nothing but this, minus 5.5264 minus 1.5323, which is nothing but y3 dash. So this will give you 0.61478, and this is the required answer for the value of x equals to 0.3, value of y at x equals to 0.3. Let's see one more example. So here y dash is given as 1 plus y square, and the values are x equals to 0, then y equals to 0, x equals to 0.2, then y is given as 0.2027. If x equals to 0.4, then value of y is 0.4228, and 0.6 is 0.6841. So now we have to find value of 0.8. So again, if you see this, then it is x0 is 0, and here similarly y0 is also 0. Then x1 is 0.2, which is nothing but y1 is 0.2027. Now x2 is 0.4, whereas y2 is, this is y2, which is 0.4228. Then x3, which is 0.6, and y3 is 0.6841, and x4 is 0.8, which we need to calculate. That is our y4. Now once again, h is nothing but the difference, so it is 0.2. First we'll use the predictors formula. So predictor formula is yn plus 1 equals to yn minus 3 plus 4 upon 3h into 2yn minus 2 dash minus yn minus 1 dash plus 2yn dash. So substituting n equals to 3 to calculate y4, we'll get y0 plus 4h upon 3 2y1 dash minus y2 dash plus 2y3 dash. So this is equal to 0 plus 4 upon 3 into h, that is 0.2, into 2 into y1 dash. So we need to calculate y1 dash. So if we consider this y dash, then y0 dash is 0, y0 dash will be 1, sorry, 1 plus this. Then this is x0, x1, x2, x3. So now y1 dash will be equal to 1 plus this square. So this will give you 1.0411. Similarly y2 dash, so this will be 1 plus this square. This will give you 1.1787. And third one is y3 dash, which is equal to 1 plus 0.6841 square. So this is 1.4681. So now substituting this value, y1 dash is nothing but 1.0411 minus y2 dash is 1.1787 plus 2 into y3 dash. So this is 2 into 1.4681. So this, after calculating all this, you'll get y4 as 1.02392. Now this is the predicted formula of predicted value, and now we have to use the correctors formula, which is yn plus 1 equals to yn minus 1 plus h upon 3 yn minus 1 dash plus 4 yn dash plus yn plus 1 dash. So now again n equals to 3, y4 will be equal to y2 plus h upon 3 y2 dash plus 4 y3 dash plus y4 dash. So again you have to make use of this y4 to calculate this y4 dash. So y4 dash is equal to 1 plus y4 square, which is equal to 2.0484 after calculation. So now substituting this value of y4 dash in this equation, you'll get y4 as y2, which is nothing but y2 0.4228 plus h upon 3, so that is 0.2 upon 3 into y2 dash is 1.1787 plus 4 into y3 dash, which is 1.4681 plus y4 dash, which we have found it as 2.0484. So this will give you 1.0294. So this is our required answer, that is y of 0.8 is equal to 1.0294.